Hello and welcome. My name is Elizabeth Kennedy, and we're here today to do a demonstration, a classic physics demonstration of getting an egg, a hard-boiled egg, into a bottle that looks like it can't possibly fit into. And not only getting it into the bottle, but getting it in without breaking or destroying the egg. So what I have here is just a regular old-fashioned milk bottle. And you can see that the opening of the milk bottle is smaller than the egg. And how we're going to do this, how this is usually done, is to take some means of lighting a fire and putting some sort of lit, in this case it's going to be a wood splint, into the bottle. So I'll go ahead and do that. But before I do, let me just make sure that I'm following safe science. Put on my safety goggles, and I have a little beaker of water to put my spent match into. So I'll light this splint. All right. And I'll set this down into the bottle. Put the egg on top. And just see what happens. And sure enough, in it goes. It's a fairly shocking and fun event for students to see who've never seen it before, which I suspect is why it's such a classic. And very clever demonstrators can then again get the egg back out of the bottle, but more about that later. One of the things that we're also going to talk about is how to take this fairly qualitative event with the smell and the sound and just kind of seeing what happened and turn it into a bit more of a quantitative experiment. And the way we're going to do this is we're going to take another bottle that's been adapted. This is the Pasco metabolism chamber to accept the pressure sensor. And let me show you what we've got here. We have a dual pressure sensor, and we're going to connect to that a stopper that will fit into this hole in the side here, and the other end be connected to the pressure sensor like this. And in my Pasco metabolism chamber, which has a hole in the side, I have a birthday candle that's been melted onto a penny, and that's just so that I can drop it in the top or place it into the hole and it stands upright, and I can place it right in the center so that I can easily then light it. Now you'll notice that the diameter of the openings is not exactly the same. This is obviously a smaller opening. Nevertheless, we're going to try this, and I'll get another egg out of my container here. And by the way, I've got my eggs a little bit moist. It helps to have them just a slight bit lubricated. So I'm going to begin my experiment, but not before I've started to collect some data. So what I have here is a graph display of, this is for the pressure inside the bottle, and then the second port will be just measuring normal atmospheric pressure while this all takes place. So I'll begin with my pressure data recording, and I'll go ahead and light the candle inside the jar, inside the metabolism chamber. Now very carefully I will insert the rubber stopper into this hole in the side, place the egg on top, and I'll just hold it in place. I'm not actually pressing with my finger. I'm just holding it in place until I know a seal has been formed. And we'll just see what happens. And as I had mentioned, the difference in the diameter between the two openings makes it look like this egg is really going to have to squeeze tightly to get in there. But you still should be able to see that it's trying. It's really trying to get in there. If I had smaller eggs available, that might be an easier task for the egg. So meanwhile, let's think about what's going on while we watch and see what happens to this egg compared to this one. We have a pressure measurement being taken inside the bottle, inside the metabolism chamber, as well as a pressure measurement being taken in atmospheric pressure. And as we can see from the graph, atmospheric pressure is about 100.8 kilopascals. Meanwhile, inside the bottle, it's about 92.2 or 3 kilopascals. So it's quite a bit lower pressure inside the bottle. Well, difference in pressure is difference in forces. So what this means is that the top of the egg on the outside of the bottle is experiencing a greater force over its surface area. And of course, force divided by an area is pressure. And so inside the bottle, there's a smaller force, a less pressure, lower force per surface area. And if there's a difference in pressure, then there's a difference in forces. The imbalanced force is what eventually causes the egg to get forced into the bottle. In this case, trying to be forced into the bottle, but having a difficult time of it. So what we can see from our pressure graphs is that the pressure inside the bottle has dropped to a value and it's holding steady there. It's not continuing to decrease. So I doubt that this egg will make it all the way into the bottle, but we can at least get a look at the difference between the pressure and therefore the force on the egg out here and the force on the egg inside. As I mentioned earlier, some demonstrators or some experimenters, some students can actually get the egg back out of the bottle. And although this egg is a little bit, it's sustained a little bit of damage from its trip into the bottle, I think that I can probably get it back out of the bottle. And it still doesn't want to come back out. It still clearly doesn't fit. But what I propose to do is to take a can of compressed air and with the little straw tube on it and press that up in beyond the egg. And we'll see. And it may not work this way. I may have to change the orientation of the egg. Looks like the wide end of the egg is facing down, so I'll try to get that changed. I'll try this again. And there it is. A little bit messier than I'd like, but egg back out. Okay. Well, thank you very much for joining us today. I have some cleanup to do. I hope you've enjoyed seeing this classic physics experiment that's normally qualitative be a bit more quantitative. Thank you.